few examples of the use of components, and in particular, we see how to do iterations and how works iterations inside OMS. Therefore, you have to select OMS3 example basics as your working directory inside the Jupyter lab, and also inside the console for who is using the console. And here you can open the simple iteration. You can close to connected here. Okay. And we open a new notebook. Okay. The other way around. Okay. In this part, you will be learning how to do iterations, time iterations. So you have a model that works doing each time for several time steps the same thing. For instance, this can be the solution of a model that goes for a certain number of time steps. And later on, we will see. Now we see exactly inside the simulation files how it works. First, the concept of the simulations. Okay, we can do. We do the usual importing. We can comment this one. We are not actually using it. Okay. Okay, I was just executing the command here, but it doesn't matter. Okay. I'm sorry. But I just have to bring it here. Can just this is wrong here. Okay, that's the same command. We are using the iteration control. It uses an iteration. So the image that show everything is this one that you see here. I am just showing here for you. In the example before, what I did was to load an image which was in internet. Here I just have my image in the directory EMG. If I go on the command on the okay, I go one. No, it's not here. It's here. We go docs. We go image, and here I have the image stored. So I just go from the directory where I am to the directory image, and I load a file which is called simple iteration PNG, which is exactly this file that you see here. How is made this component? Actually, we could give a look to the source code, but because there is also the source code of this iteration here, for who is interested, can go here, go to source. And our example, I don't remember the name, 0.5 iteration control. And this is as you see, a Java file. You don't understand how Java works, and you don't need to understand for this class, for this school. But you see here how in Java input and output are assigned with these things which are called annotations, and that distinguish what is it the input and what is the output. So this particular example here has also the code in the source code, and actually the first time that we built it, it is also compiled, the source code. The component take an input, which is a number, let's say 5. It goes inside the iteration, inside the component, and what the component does is just go through an iteration 5 times. The iteration is controlled directly by OMS. It's not Java code. The original program is in Java, but what controls the iteration is the Java simulation file that we are going to see in a second. So, in this last 5 times this work. Now, what we can do is to go up here and see in the simulation, which is a simulation simple iteration. And okay, this is just okay. The simple iteration you see in this code, in this part of the code, you see that at the beginning there is OMS3.sim, which is a simulation. The name of the simulation is missing. In fact, the name of the simulation is actually not mandatory. Sorry that I put my wrong glasses. So, and as first here we don't have the correct indentation is like here, and there is a variable which is cdone, which is done, which is a Boolean variable, meaning is 1 or 0, true or false. While this variable is true, an iteration is performed inside the thing. So the other thing is we have a variable which is called ccount, whose number is 5, like it is written here. And you have C. We have simply a component C, whose real name is exercise 05, EX05 iteration control. Internally, what it does is take this number, is called internally iteration control, but for us is called C. In a sense, we have anticipated it because we have seen over there. And when we execute, what it does, it just simply take this 5, then it decrease by 1 the value, and do something, decrease by 1. When it is 0, everything is completed. In this case, the Boolean value is deferred to a variable which is inside the program. So you, as an OMS programmer, you cannot do. You have the programmer who did the components has to say here, hey guy, here there is an iterator that you have to define. The iterators is given by this has this internal name. You can call obviously as you want, and it takes a field, a variable, which is count, and you have to assign an integer number to it. So if you go to, again, to the simple iteration, this is how it works. Here, actually, in the example, you have the whole code. And what it does is exactly what I told you. But as you see, if you can understand a little bit the code, let's say that just this code here, which is quite independent on the nature of the language, say if the internal iterator is 0, then put it to the variable we have in input. Then what you do is just decrease 1. In this code here, you don't have any other, you don't have internal iterator in the code here. You just decrease the variable by 1. What actually does the decreasing is the simulation code, which is written here, which I already showed to you. Here you can see it formatted. Haha, this is another thing that you can think. If I click 2 times here, you see that it is a markdown cell. And when you want to include the code in the markdown cells, you just put these 3 things here, you know. Then I put the language in which I suppose it's written the code that follows. Here it is Groovy. And I close here the code here. So when I go and I have to execute, so I go to give a Control Enter or to execute this for producing the syntax highlighting in the text, and I have the code perfectly formatted. So my run here. Okay, you see anticipated what it happens here, but you know, if you just go and execute, there is a bug in my version of the Jupyter Lab that sometimes I'm not able to push down at the end the cells to move down when I drag them, but I can do the reverse, put them out. So now it's in the correct thing. If I go to execute, you see already the result here. I am not in the correct directory, so I have to do the right operation, which is I have to go to the right directory to run the things. So my directory is just the one you see. You don't see actually, but is now I can write on the other side. No, okay. It's very long. For you, it's different. For who you can use who of you can use Docker? The minority of you. Okay. In the Docker, you have this example here. Now you are in the right things, and you change the directory, and then you finally issue the same command that you have here, and now it works. Does almost nothing, this command, which is control43410. As usual, in many languages, the the numbering of things start from 0. So count of 5 is 0, 1, 2, 3, 4. If you run from the console, you have to launch the console. You have to launch the console again. So, okay, this was. Okay, I have to. The console is here. So you launch the console. Okay. What you do is you can even in the console you can even leave the command. So we can see the console here. Okay. Now also in the video you see the console, and what we do, we go and click here. We go in. Okay. I have to change my.
Also, we want to, for example, we want to iterate it not just for example, 80. We should go to the simple iteration.
Yes, if you is the next operation that we will do in a moment. You will I will ask you to run 10 iterations instead of 5. So you have to modify one thing. Example basics. Okay, okay. Why is not taking it? Okay. Okay, now it is right. I select the simple iteration and I execute. I give some wordings here because of the thing. And what we want to do here, if we want to change the number of iterations.
In console, we can. In console, by changing.
Exactly.
Yes, but in Jupyter, it doesn't work.
We see in you have to change the sim file.
Yes, I've edited, but
you have to save it.
Yeah, it works in.
Let's see.
Console.
Let's see. We see here in the console how it works. Now we change the we change again the thing, and we go to the application windows, which is this one, I guess. Okay. And now, sorry, but I have to recover my windows here. Okay. You go to simple iteration, the sim file, open the file, write 10, overwrite the file.
How can we write?
It asks for you.
Yes.
And now I run it.
Oh, it doesn't work.
here it works. So maybe now please try yourself to do these simulations. It should work for you. I wait an answer from you all, otherwise I don't. And that's essentially the way you change the things in any simulation. You go there in the sim file, you change the variables, and yeah, everything works. It's pretty easy, but you can also do.
Professor, go to the simple iteration doc. Not simple iteration. In the portal.
Yeah. Now someone is coming to you to see the what happens to you. Yes. Instead, we go to another type of iteration. Okay, I am not in the right way. I have in. I go again to doc. Okay. Now I believe that it's not necessary for me to rewrite the things in the. We can also cut the backlinks here. Yes.
And the iteration, the simple iteration notebook. How does it know that he has to execute the module method in Java?
In which
you can scroll up a little bit.
Yeah.
Okay, here we're saying that he has to call the class iteration control, right?
Yeah. This is the sim file.
Okay, and how does
you first read the component. You have one component, which is X05 iteration control. You don't have any other way to know that there is an iteration control class inside your components, either than deducing from here, reading the Java code, or having this information from elsewhere. So if you are a good programmer, you provide all the three information. If you are a programmer in a hurry, you don't do. But the other guys can eventually go and inspect these things and try to understand that there is a variable which is iteration control. Then you go, here parameter is up, but it should be probably be reverse.
Yeah, but the order is not important.
The order is not important. That's the one of the things to remark here. But the conceptual order is the other one, where you first define the components. Because otherwise you didn't know here that actually there is a little bit a problem, let's say, because here at the beginning on the external, you have to know the C. There is this C done, which is actually specified internally here.
So, but anyway, parameter is executed only once. Otherwise, each time I'm looping there, I set again parameter to count to 5.
Yes. Yes, exactly. The parameter is read once for the whole control, and then it is internally. It's not like it's not exactly any like normal programming.
To understand it, it should be outside the while.
Yes, exactly.
Okay.
In a normal programming, this C done should be right here externally, and because otherwise here for the normal concept seems that it is anytime retaken, initialized at the same time. It's not initialized here exactly.
If you go up on the Java code,
Yeah.
here, for example, if I have another method, is the execute tag there that tells us?
No, there is only the workflow of the model is in the execute part.
Okay, so the method has to be called execute.
Yes.
Okay.
This is what in a normal Java class you call main.
Okay.
This substitute the main.
Okay.
And in place of this is not clear to not Java program for non-Java programmer, but who has some knowledge of C knows that any C programming is executed. There is a method which is called main, which is executed, a function, a subroutine, as you want to call it, called main. In OMS, there is not the main, there is that execute.
So the method has to be called execute.
Yes.
You can have also other methods, but they have to be called by the execute.
Yeah. Other methods are called to execute. Okay. Execute here, obviously, internally to OMS, you should not have another main, because below this level there is Java or there is Groovy, which recognize main in a different way. So this is the main of the Java of the of the object modeling system.
Probably you need to have a main if I want to test just the component.
Yes, if you want to test just a component, you can just change this to main and run as a normal Java code.
So those tags like in, execute, at execute.
Yes.
Those are things of OMS, right?
Yeah, these are things. Actually, the annotation is a general feature of Java and also in Groovy. That is a particular of languages that is called reflection, meaning that you can put this annotation inside the code for letting you know at the runtime what the code is doing, or giving information about the code. So, for instance, I can, with this annotation, I can build another program that read this program and tell me which are the input, which are the output. In fact, we had a version of some of our tools that did like that. We put this annotation in the Java code, which is useful for OMS, but we also had an interface builder, which build a graphical interface for any component, where you have the input and the output already set up automatically, just for reading from the internal of the code, which is a little bit advanced, like an issue, but yeah. Time iteration number 6. Okay. Here, time iteration in this case is made in a different way. Time iteration goes through a schedule. Let's say we have initial data and final data. We have another calendar field which say which day of the year, and another variable which is called amount. All these variables are given to the first component, which is called time control, and it gives out a variable which is called current. The current variable, the current actually time, because this components is not doing anything special. This is given to another component take the current time and print the time. Nothing special, but it's just to see how the control works. So I don't show to you the Java code, however, it is here. I just show you the simulation file, which also we can open differently, but here is much better formatted. So you also notice that we always import this one. For you is nothing important, but this just call the iteration builder, and what we do, which are the components we are using. We saw from the figure above. In this sense, this figure above do the job that we need for knowing which are the variables that any component get in input, and which are the variables that any component have in output. So here we know that we have start and calendar field, cal field, amount in input, and we have current in output. Vice versa, in the other component, we have current, which is in input, and then we know that gives an output which is actually on the console, not as an information which is passed away. Another important thing that maybe today I didn't remark enough is that the passage of data between the components is completely done in memory. Potentially, you can do the same concept here between components, writing file and reading file. Here, the connection in OMS take care of the fact that everything is passed through memory. Give the address in memory and get the address in memory. So component, let's say 20 years ago, we already did some form of componentization, writing files. But this is a huge waste of time also in computation, because writing to a disk, even in a modern current SSD, the time of accessing the disk is much slower than the time in memory. So this is another aspect that maybe we don't care anymore so much, but is still also important. So we have two components. One component which is time control, and the other which is time consume control. Time consume control, actually consume here is a keyword in informatics, meaning that where there is the word consumes means that it takes some information and use the information and then cancel it. It's not existing anymore. Everything which is consumed is consumed. So we can expect that the second component take the time, use it for something, and doesn't return anything. Internally, these are the name of the two components. Now we see how they are connected. We say that current output is given to C1 current input. Here, the internal variables of the two components have the same name. This is not mandatory in general. They could have different name. They could have named the variable in the second component foo something, this thing, whatever. Simply, I would not have this name here. So you have two components, they pass an information between each other. We have a while here, and even here, the scheduling is done to a CDAN. And it is a Boolean which is taken to 0 at a certain moment when the last date is, in this case, produced. The first variable is, okay, I say that you don't use Java, but there is a command, a Java command here, actually. This is a Java command. But what it does, we can have done in a different way. But the Java who is in us, not only in him. His last name is Java, so is here I am creating a class where I say September 1st of September 2001, and there is because this sim file is actually a subset of the Groovy language. I can also issue some Java command inside if I know the right things. And this was done on purpose to see that this is possible for more advanced users. But actually, you can specify the data like this one is 2001 10/10 until 10 of October. The double time is there is a Japanese feast, the 10th of October. No, double time. And cal field is Java util calendar day of the year, and it transforming the day of the year. And C amount is a variable internal number that increased the date by 1. So now we go and run it. Okay, as you see, it just print actually October 1 to October 10. Okay. This is what I think now you can try yourself to do some changes in the variables while I take a little rest on. I actually don't know. It should start from September actually, but let's try also to execute outside, so we will see what happens.